Hello and welcome back. So, you want the good news or the bad news? The good news is the first two sections in this chapter are a piece of cake. The bad news is all the rest of it is some of the hardest stuff you will have to do this entire year. Sorry, that's just the way we are right now. It's really hard stuff. It takes a long time, takes a lot of time and commitment in order to do this stuff. So do me a favor, stay focused, stay aware of what's going on, stay aware of your time and how you're spending your time. Don't take a lot of breaks or else it's going to take forever for you to get through this stuff, and we really need you to get through it and understand it. So we're going to go ahead and jump into today and tomorrow. And then after that, we're going to pray we can get it all understood. For today, we're doing prime factorization, which I know you already know because I've helped you with it before. But some facts you need to know just as background information. A prime number is a number that has only two factors, one and itself. A composite number is a number that has more than two factors. Any number can be written as a product of prime factors. That is the fundamental theorem of algebra. It is the only thing that I learned in my master's program that I actually use. That one right there. And the act of writing it as a product of prime factors is called prime factorization, which is what we're doing today. So let's talk about the number 6. The number 6 has different numbers that can go into it evenly. So 1 goes into the number 6 evenly, 2 goes into the number 6 evenly, and 3 goes into the number 6 evenly, and 6 goes into the number 6 evenly. All those can be divided into 6 evenly, which means that all of these are factors of 6. If we talk about the number 7, well, 1 goes into 7 evenly and 7 goes into 7 evenly. So these are the factors of 7. That's all the numbers that go into 6 evenly and all the numbers that go into 7 evenly. If I count up how many factors I have 4 factors. 4 factors is more than 2, which means that 6 must be a composite number. Here, there are only 2 factors, 1 and that number, which means that 7 is a prime number. There are some other things you need to know. There are 2 numbers that are neither prime nor composite. That's the numbers 1 and 0. So if you're making a list of prime numbers, your first prime number is not 1 because 1 is not a prime number. Your first prime number is always 2. Doesn't mean that it goes into everything. It only goes into half the numbers in the world. But 2 is the first prime number. Okay, let's do real work. I would like for us to find the prime factorization of a couple of numbers. We're going to start with the number 18. If I wanted to find the prime factorization of 18, it means I have to break it down into a product of prime numbers. So I want to know numbers that go into 18 evenly, that are prime. Well, we said 2 was a prime number, right? The next prime number is 3. The next one is 5. And then the next one is 7. So just using those 4 numbers, I think you could do most of the problems in this section that you get. Just those 4 numbers. So, for number 18, what of those 4 numbers goes into 18 evenly? Well, the first one I see is 2, because 18 is 2 times 9. So that's what I'm going to break it down as. Since 2 is prime, I'm not going to mess with it. I'm just going to break down 9 again. And 9 is 3 times 3, and we know that those 2 are both prime as well. So now I have prime numbers here for 18. And since I have circles on all of my bottom numbers, that means that I'm done and I can go ahead and write my prime factorization. So it's 2 times 3 times 3. But because we're not in elementary school, we have to write it in exponential notation. So now it's 2 times 3 squared, because there are 2 3's. Simple enough. One for you to try. The number 36. Take a few seconds, because that's all it should take, and break that down into its prime numbers. Okay? 36, I'm going to say, is 6 times 6. Neither of those are prime because they weren't in my list. It was 2, 3, 5, and 7. So, since neither of those are prime, I'm going to have to break them down again. That's 2 times 3. Those are both prime. And this is 2 times 3. And those are both prime. So when I make my list, I have 2 squared times 3 squared. Two more problems for you to try. 50 and 72. Pause the tape, do what you can. Okay, so for 50, that's 2 times 25. 5 times 5. 2 times 5 squared. And then for 72, I don't know whether you chose 2 times 36. Some people do. Or if you chose something like 8 times 9, a lot of people choose that one. 3 times 24, nobody ever chooses. So that's the one I'm going to do. Because I know you didn't do it this way. 24 is 4 times 6. Neither of those are prime. So that makes it 2 cubed times 3 squared, because you can't forget about the one that's up here. Now, when I was in fourth grade, we had homework on this, and the homework that we had to do was write the prime factorization for every number from 1 all the way up to 100. That is not your homework. That is certainly not your classwork. It takes forever and it's pointless as far as what we're getting into. So I'm trying to keep this as relevant to what we're getting into as I possibly can. So since you've practiced some prime factorization, which is basically the fun stuff, I'm giving you very little homework and classwork in this so that I can make up for it later on when I give you a bunch of homework and classwork in a couple of sections from now. So on page 272 in the practice exercises, Your classwork is numbers 1 and 9. I know, just 2 problems. Odd ones, so you know the answers are in the back of the book. Or they should be. Your homework is number 3 and 21. Look at that. I even made it relevant. Didn't give you the great big huge numbers because once again there's really no point. But that's it for this section. The next section gets a little bit more into it, into the chapter, but really I need you to stay focused with all the stuff that we're doing in this chapter because it never goes away. It's worse than solving equations is for showing up all the time. So, see you tomorrow.